All right, good morning, everybody. Happy Tuesday. Happy third week of remote learning. We are starting actually a new unit today, and it's one of the most important units in Algebra 1. It's on quadratics, or parabolas. We saw examples of those graphs last unit with our transformations, but more to come on that in a second. So hopefully y'all are having a good day and a good weekend since it's been a few days since I saw you last. So I appreciate y'all being here. Let's kind of move into the material for today. I'm going to start off. Hold on, Neil. For some reason, it does that, where it kind of cuts off the top left-hand portion of the screen. All right, I want to start off with a couple of quick announcements. I'm actually going to start at the bottom of that screen on number 6, rather. Spring break is next week. We'll kind of circle back around to that, but I wanted to mention that spring break is next week specifically because we have Edpuzzles and assignments due this Friday. So what you see there in number 1, lessons 21, 22, 23, 25, 28, and 29 are all due this Friday or set up to be due this Friday because I wanted you to try to get all of your work done before spring break and not have to worry about that over next week. Now, I know you can't go anywhere next week or whatnot, so it's not going to be as much of a spring break as maybe in the years past, but effectively what you can do is not worry about getting work done. So long story short, please get those lessons done and turned in by Friday. And just a heads up, y'all, we did 21 through 28. All of those lessons, a majority of them, were actually done and discussed in class together before we went to this remote learning setup. So really the only new lesson that we've done since moving to this setup is lesson 29. Also, 2 Edpuzzles due, the parent graph and the transformations. Those are due by Friday as well. Please try to get those in ASAP. A lot of you have done a really good job with getting those in, but still a lot of missing or unsubmitted assignments so far. So just kind of a heads up on that. Speaking of Edpuzzles, we have 2 new Edpuzzles that were posted today. They're on the Intro to Quadratics. They're talking about specific portions of quadratic graphs and the equations that we'll be looking at. Please, please, please get those done. They're not due for a while, but I want you to kind of work on those because they are, again, supplementary, meaning extra help with the new material. So keep an eye out for those if you haven't logged on to the Google Classroom yet, which you probably had to have to get to this Zoom session, so that's kind of a simple statement, but you should see those new Edpuzzles posted today. All right, do I have any questions before I move into number 3? Anyone have any questions on assignment due dates, how to submit assignments, all that good stuff? If you do, unmute yourself and I can see who's talking, or you can type it into the chat. Sweet. Okay, if you do have a question, you're typing, no stress, continue to do so. We are going to have a member of the ASB, or a hopeful member of the ASB Executive Office, going to be joining us today. Logan Hubbard is the name, and at 11:55, the very last few minutes of class today, Logan's going to come in and talk a little bit about ASB elections for next year and how it's going to move forward with this remote learning situation. Great question, Ashley. On the remote agenda, are the page numbers the homework? Yes. So actually that's taking us to our next concept. So that's a perfect segue for me, Ashley. Thank you for asking that. Number 4, remote learning agenda, use the new one. And by the new one, I mean this one, the one that's on the Google Sheets that has this multicolored situation. Ashley's question was, are the page numbers the homework? 100%. So like, for example, for lesson module 4, lesson 2, which we're doing today, sorry for the lag, we have 2 Edpuzzles as mentioned. We're actually going to try to get the homework done in class today. That's our goal. But effectively, these pages right here, page 417 to 418, that is the homework for lesson 2. And the problem numbers 1, 3, 4, 6, 8, those are the actual numbers that you need to do on the homework. So for lesson 3, which would be the next one down, we're going to be at page 427 to 428. For lesson 3 on quadratics, you'll be doing numbers 1 through 3. So totally great question. That's titled pages, the column G. Those are the page numbers that you need to do for your homework. Fantastic question. You can also reference the homework logs. Traditional homework log. This is the module 3 one. This is all the stuff that's due this Friday. Notice that 4-3 time frame. And you can get pages there as well. Okay. All right, but if that answers your question, I hope it did. I want to kind of segue back or return back to this. Make sure you use this learning agenda. All it is, basically, everyone, is it's what we're learning on which days. Today is the 31st, so we're going over lesson number 2 and what the homework and the actual classwork is. So just use that to your advantage, and please use this moving forward if you have any questions about that. All right, let's go back to our announcements. A couple more things. One more thing, realistically, because we already talked about spring break, but use the RLQs. RLQs are the things that a lot of you have been participating in. These Google Forms that I've been posting to ask questions. As a matter of fact, I posted one this morning. I already have 2 people that have asked questions on it, so well done. Feel free to continue to use those to contact me to ask any questions that you have, like homework questions, concept questions, clarification questions, anything. I'd be happy to answer that. Also, always feel free to ask via email or log onto these Zoom sessions and ask me in person too, okay? All right, spring break next week. That's the last thing. Right on. Okay, before we move into today's actual lesson, does anyone have any specific questions that you want me to tackle right now? If not, we're gonna start moving into learning about quadratics. And by the way, I do appreciate y'all being here. I really do appreciate that. So thank you for that. I see more people kind of logging on, and that should be perfect. Rex, who has Covet? That has nothing to do with this class, does it? All right, right on. Okay, cool. So today what we're doing is we're being introduced to quadratics, functions, graphs. We're going to talk about the parts of parabolas. That's already been put up. Actually, I just put another post up on the Google Classroom. I'll kind of reference that in 1 second. And then what we're going to do to kind of get through today's material is to go over pages 417 and 418, specifically those 5 numbers that you see, 1, 3, 4, 6, and 8. Heads up, y'all, this is a homework. We're going to do some of the homework today in class. So like I would recommend getting your textbooks out or a blank sheet of paper out and using this as an opportunity to get lesson 2 homework done, because we're going to do homework together in class today to explain the introduction of parabolas. It's mostly a review lesson. Right on. Okay, so here's a quick definition of parts of a parabola. Again, I posted something on the Google Classroom, which I'll switch to in about 30 seconds, but a parabola is the blue curve. It is defined with a quadratic, y equals x squared, aka these always have a power of 2, and hence why there's 2 parts to this parabola, 2 forms of movement. More to come on that in a second. 3 big things that we want to talk about for the parabola are the axis of symmetry, which is denoted there in orange. Axis of symmetry is a middle line. It's basically like the mirror or the halfway area. The axis of symmetry always runs through the vertex. The vertex is the lowest or the highest point of the parabola, depending on how it's open. And then the x-intercepts mean they intercept or run into the x-axis. Those are always going to be the solutions, like no joke. I could summarize basically an entire unit of quadratics right now and say that anytime we're trying to solve for a quadratic, a parabola, something to the 2nd power, we're looking for the x-intercepts, which is just a fancy way of saying the values of x that make y equal to 0. So Google Classroom right here. This is what I just posted like a few minutes before we started off. So again, the axis of symmetry is in the middle of the graph. It's an invisible line that cuts it into 2 equal pieces. If I have a quadratic, the axis of symmetry allows it to be separated symmetrically, or in the same size but open in opposite directions. The vertex is the turning point. In this case, in my example, kind of mirroring my face right now, the vertex is where my wrists touch. It's the lowest point. If we flash back to the unit we just finished, we talked about those A's, the H's, and K's. We said that A value determined the stretch of a graph and also determined whether it opened upwards or downwards. The same is true with quadratics. If that leading coefficient or the value in front A is positive, the graph is opening upwards. Last but not least, and again, the most important part of this whole section, x-intercepts are the solutions, which is a fancy way of saying, or a math way of saying, I guess, not so fancy, but mathematically speaking, where the values of x that make the whole thing equal to 0, the output, the y. If you could find the x that makes it all equal to 0, you have found the solutions to the quadratic. Sometimes referred to as roots, like roots of a tree where it hits a height of 0, and zeros because they're the values of x that make y equal to 0. So that's kind of the main parts of a parabola. Notice that I'm looking directly at the Google Classroom. All of this information, including the image here, is up there as a material post, the most recent post on your Google Classroom. Please feel free to use that to your advantage, although it seems like the post did not want to put up the image, so I'll fix that in a second. All right. That's basically it. So let's move into the lesson here, okay? We're gonna kind of use those vocab words continuously. Again, this is our introduction lesson to a whole nother unit. So today is kind of getting our feet wet metaphorically, meaning kind of being introduced to these parabolas at a higher level than our transformations did, and then starting to kind of get comfortable with it over the next month. This is really where we're trending for the entire next month, is working on this stuff. All right, so now what we're doing is we're on page 417, lesson number 2 in your textbook. So I'd recommend getting it out. As I mentioned, we're doing the homework together in class right now. So behooves you or benefits you to get this out. All right, number 1 on page 417. And I know normally when we're in class together face-to-face, I kind of bother you about asking questions. Some of you love it, some of you hate it, but I'm gonna do the same thing right now. If any of you can give me one reason why these two parabolas on page 417 should be grouped together, please either unmute yourself and let me know or type it into the chat box. So I'm gonna go about 30 seconds here, y'all. You know what? 30 seconds on number 1. Go back to the timer, it's been so long. Let's go 30 seconds on number 1 in page 417. Can anyone give me a reason why these two parabolas should be grouped together? Yeah, good call, Andrew. Good call, Danielle. Nice, didn't take 30 seconds. Sweet. You know, I'm gonna pause it then because we already did that. Right on. Danielle and Andrew's answers are 100% correct. They both have the same vertex. They're the same but flipped across. Right on. So what Francis is saying, one has a negative A and the other one has a positive. So what Caitlin and Francis basically were saying is this. This one, the red one, has a positive A because it's opening upwards, has a positive demeanor. Let's do this. Y'all know the cheesy smiles I make, okay? So that one has an A that's positive, no doubt. This one's gonna have an A that's negative because it's opening downwards. So that's actually a contrast, meaning a difference between the two, but I love the fact that we noticed that. But what Danielle and Andrew were saying was that their vertex on both of them, the purples, were the same. And on both of these graphs, the vertex appears to me to be at 2, -3. 2 over, -3 up. Right on. Andrew then took it to the next level and he said, all right, well, if the vertices are the same, if those purple dots are the same, then their axis of symmetry is the same. And he's 100% correct because the axis of symmetry always runs through the vertex. So the axis of symmetry is this green line. That's my AOS. I'm going to abbreviate axis of symmetry as AOS. The axis of symmetry is the same on both of them because the vertices are the same. So the axis of symmetry again cuts it in half, and if the vertices are the same, the axis of symmetries have to be the same. Right on. So let's officially answer this question. I'll do this in purple. One reason was the vertexes, or the plural form of vertex is vertices, are the same. Right on. And then the second reason, we doubled down and said the axis of symmetries are also the same. Sweet. Hey, good answers, y'all. I appreciate your hard work right there on number 1. Okay, so what we're now going to do is I zoom out here on page 417 is cruise on down to number 3. And we're talking now, flashing back to this idea of the parent graph here on number 3, parent graph equals y equals x squared. Does anyone need number 1 up on the screen anymore? Speak now, forever hold your peace. All right, we are cruising down to number 3. Parent graph, we mentioned parent graphs are the most basic graphs. So the parent graph of a quadratic is the most basic quadratic. Again, it is y equals x squared. Notice there is no visible a, h, or k. Okay, there is no visible a, h, or k from our transformation template. H is 0, k is 0, which is why our vertex is at 0, 0. And we kind of flash back to that beloved math wrap, which, you know, I haven't put up on the Google Classroom. Maybe I will for your enjoyment, because this was one of the 3 that we talked about in that math wrap. But Effectively, what we know we can do to graph any function, like legitimately, no matter what it looks like, no matter how intimidating, no matter what the numbers, is we could use two things. A table, or rather we could use a table and do two things from it. The table allows us to do two things. It allows us to substitute and then use PEMDAS to solve. Okay, that's what every table allows us to do. We pick random values of x, we sub them in, and then we use PEMDAS to solve it out. Well, let's do that right now because we actually have an equation that we're trying to graph, y equals x squared, and they were so kind to give us a bunch of values of x already. Notice that some of my favorite numbers, they just took it a little bit further than I normally do. So here we go, let's solve, ready? Y equals x squared, but now x is no longer x, it's a what? It's a -3. So we're gonna take that -3 and we're gonna square it, and -3 times -3 is 9. So let me do this in blue. When x is -3, we substituted in for x the -3 there, and then we squared it, meaning multiplied it by itself. -3 times -3 is 9. We'll do this a little bit quicker here after I get through a few of them. Y equals x squared, but now x isn't unknown, it's defined as -2. So -2 squared is -2 times -2, or 4. All right, two more and then we'll fill them out rapid fire. Ready? Y equals x squared, but now x is, little substitution, -1. Remember, we substitute, then evaluate. -1 squared. PEMDAS says we're going to do the exponent first here. -1 times -1 is +1. And last but not least, when x is 0, y equals x squared becomes y equals 0 squared. And what's 0 times 0? None other than 0. Now, as we continue to work our way up here, 1 squared is 1, 2 squared is 4, and 3 squared is 9, we get our answers. Does anyone have any questions as to how I filled out this problem number 3 on page 417? I see the remote learning schedule. I will put that up in 1 second. Cool. So we all good with how I got these answers? Nice. Good. So as you might notice, there actually is going to be, let's graph these points. I have -3, 9 as my first point. So 3 to the left, 9 up. Could be right there. My second point we said was -2, 4, 2 to the left, 4 up. Right on. My third point, -1, 1. Just working my way down. 1 to the left and 1 up. My fourth point, 0, 0. Boom. My fifth point, 1, 1. My sixth point, 2, 4, and my last point, 3, 9. Cool. That's how we turned all of these points highlighted in green right now. All of that stuff highlighted in green. We took each of those points and dropped them down. 3, 9, 2, 4, 1, 1, etc., etc., etc. Now, what do you notice about this? It is a parabola. And how is it opening? It's opening upwards because as I connect my dots, it's trending towards up. And we can see that like such, moving upwards. What's the vertex? The vertex in this case, since it's an upward parabola, is at the point, lowest point, 0, 0. Boom, there's our vertex right there. Where's the axis of symmetry? The axis of symmetry runs down the middle here, right through the vertex. Sorry, that was not a really good color to do that. Let's try red. Axis of symmetry is in red. It runs right through the vertex. And let's kind of use our knowledge of transformations like we have previously. The reason why this one is opening upwards is because that number in front of x squared is a 1, and that 1 is positive. So again, it is opening upwards, kind of like Francis told us in the group chat earlier, that if the a value is positive, the number in front of your variable squared is positive, it's opening upwards. As this one is, it has a positive demeanor, hence the smiley face there. All right, kind of combining our knowledge of a variety of things here in number 3, what it means to graph by using a function table, check. What it means to graph by taking those values from a function table and putting them in ordered pairs, and then connecting it all to our knowledge of transformations, positive a in front, positive graph, kind of like a positive slope, so to speak. All right. Are we all good on the parent function, what its graphical form looks like? Kind of actually seeing it. We've seen this parent function many times before, but now just kind of reiterating it for the sake of this conversation. All right then. A real quick aside, we have a few minutes. We still have some time. I'm going to put the remote learning agenda up for about 30 seconds because that's the best to go. It is also up on the Google Classroom. It's in like a ton of posts, but I will make sure to post it again. It was posted with this link today, so feel free to access it there as well. Right on. So if you notice, we already did numbers 1 and number 3 of the homework. Okay. So we're gonna move on to 4, 6, and 8 in a second. Since this is complete, do we just take a picture? Yeah, once you've done this homework and any homework, take the picture and don't send it to me, but upload it to the Google Classroom. To submit all homework, so before we jump into 4, 6, and 8, y'all, to submit all homework, go to the Google Classroom. Go to the classwork tab, which is currently at the bottom middle of my screen. It'll be at the top of your screen if you're on a laptop or a tablet, most likely. And then go to the assignment. Notice all these ones old assignments because those are the ones that we did before going to remote learning. But like, let's say, you notice these ones haven't been posted yet, but they will be soon. Ah, there we go, okay. Let's say you wanted to submit lesson 29, the one that we did last week. All you got to do is go to the classroom. Again, this is my teacher version, so it's going to look a little bit different because I'm looking at all of your work. You'll only see the ability to submit. And then you could take those pictures and drop them in there. On Thursday, we're going to learn lesson 3, which is going to be continue to work with quadratics. Do we submit 21 to 28 homework on the Google Classroom? Yes, but Andrew, I believe you already submitted most of those to me in person. So if you've already turned them into me before we left for remote learning, meaning if you turned them in person in class, it's already in your Infinite Campus, so you should be good. Okay. So Andrew, the answer to your question for you is no. Everyone else who hasn't already turned in your homework, do submit it to the Google Classroom. Okay, do submit it. The way that you can check to verify is look on Infinite Campus. Infinite Campus is still your gradebook. All right, that was a quick little tangent. Let's get back to business here, and let's cruise on down to page 418, number 4. The nice thing about page 418, number 4 here, 4, 6, and 8 specifically, is that we are working with kind of a reiteration or a review of concepts. So we're given 3 different forms of functions. One is a graph, obviously which one that is. One is a table, and one's an equation. Okay, and we're asked to evaluate each of these values, f of 0, f of -3, and f of 5, using those 3 forms. So again, it's kind of a practice form of solving and evaluating, but remember, evaluating just means to determine or to solve. So on number 4 here on page 418, we want to evaluate f of 0 from the graph. So when we're looking for f of 0, that means that we're solving for where x is equal to 0. On all of these, by the way. Anytime you're looking to evaluate a function notation, remember f of x is our preset form. It's our function kind of standard form. So when we say f of 0, it just means, hey, make x equal to 0 and solve for it. So what we're going to do here to solve for f of 0 is we're going to cruise up to our graph, and we're going to figure out where x is equal to 0 right here, and I'm going to find where it exists on my graph. Boom, right there. So when x is equal to 0, what is my output? What's my height? 1, 2, 3, 4. So when x is 0, f of 0 is 4. Right on. Can anyone tell me what they think f of 0 is from the table? So again, we're looking for where x is 0. So let's cruise to the table, find where x is 0. Well, here's x, and boom, that's where x is equal to 0 right there. So what's the value when x is equal to 0? 1. And last but not least, from an equation, if we're finding f of 0, what we're going to do is we're going to substitute in for the equation. We know that in this equation, f of x equals 3x squared plus 2. Just rewriting the equation here, y'all. Zooming in on it so it's easier for our eyes to see. And heads up, y'all, this is a quadratic. How do I know that? Boom, that 2 right there tells me that that's going to be a quadratic, meaning it's going to have some sort of parabola-like motion. But for this context, we're looking for f of 0. So really what we're going to do is we're going to turn any x that we had, anywhere that we had an x is going to become a 0. So this x becomes a 0, and voila, this x becomes a 0. No, just 4, 6, and 8. Just 4, 6, and 8, Francis. And then we're going to use PEMDAS. PEMDAS says we do parentheses first, parentheses just a 0 here, so we move on to exponents. What's 0 squared? 0 times 0 is 0, so we did the exponent first, 0 squared, which leaves us with 3 times 0 plus 2. Then we work it down. 3 times 0, multiplication before addition is 0. 0 plus 2, our final answer is 2. All right. That is number 4. Let's use this as a guiding light here on 6 and 8. I'm going to go, since it looks like no one felt the need to answer on the first one, which is totally fine, I'm going to go about 1 minute to do number 6. Please try this on your own, and then I'll take volunteers, or if you finish it quickly, you can type it into the chat box. We're going to talk about number 6 solution-wise in 1 minute. 6, value -3. Again, if you know this answer already, you can start typing into the chat box. Francis got all of them already. All right, I see you. And they look correct. Nicely done, man. Okay. We only had a few seconds left, I'm sure anyways. Yeah, but Francis has given us the answers. He said, hey, the first one is 2. The second one, part B, is 5. And the third one, part C, is 29. Here's how we got them. Great work, man. We were looking for f of -3, so we cruise over to where x is -3. We work our way up, boom, right there, and that's at a height of 2. So Francis is correct. When we use the graph, we get a height and output, a y value of 2, because that's where the graph existed when x is -3. Nice, man. On the table, we find where x is -3, and then we look at the output, which is 5. Sweet. That's how he got 5 for B. And then the last one for part C is he evaluated f of -3, and he did PEMDAS, meaning 3 times x squared plus 2, but now x is no longer an x, it's a -3. So he did exponent first. What is -3 times -3? 9. Again, what he did there is he did exponent first, -3 squared, gave him 9. And then he did multiplication. 3 times 9 is 27. And then addition, 27 plus 2 is 29. Right on. All right. Last thing in this homework assignment is number 8 again. And then you are done with lesson 2 homework assignment. Any of us who are here or viewing this as a recording, we're going to get that done. So make sure you take pictures of these and then upload them to the Google Classroom at your convenience. All right. Number 8, f of 5. So again, this is where x is 5. Cruising over here quick. We'll do this together so we can get some time for questions. When x is 5, I go over to where x is 5. 1, 2, 3, 4, 5. Yep, that's 5. So where does this graph exist when x is 5? It does not exist. Trick question. You could use this, boom, or does not exist. Before I move forward, does anyone have any questions why the answer to 8A does not exist, or null set? Null set is a 0 with the dash through it. Because if x is 5, notice that this graph stopped here. The domain ended at 4. The domain only goes from -4 to -4. It's -4 to +4, so boom, there we go. Okay, what about when f is 5 from the table? Same answer, same answer. Does not exist because after I copy and paste this right over here, because if we look at our table, notice we don't know any information about when x is 5. And then Francis said he thinks he has an answer for part C, f of -5 here. And let's see if he got it right. He said f of +5 would be equal to our equation 3x squared plus 2. But again, he knows that x is now 5, so he plugs in 5 for x, and then he evaluated. Exponent first, 5 squared is, 5 times 5 or 25. Then he did multiplication and addition. 3 times 25 is 75. 75 plus 2 is, great call, Francis, 77. Nice, man. All right. There is lesson 2. Again, we did 2 things today. As I zoom up, we went over the parent function of a quadratic. Okay? We went over the parent function of a quadratic and defining characteristics of a quadratic, and we used some compare and contrast here on number 1. We compared that the axis of symmetries there in green, the middle sections were green, and the vertices purple were the same, and that's what made them group together. But then we also saw a little contrast, meaning where they were different is that one was opening upwards and one was opening downwards. Sutton, are we good? Okay. And then after doing all that, we took a little flashback to our past and evaluated, aka solved for graphs via solved for functions in function notation form via graph, a table, and f of x function notation form via substitution. All right. And it was all predicated around our intro to quadratics here, y'all. Our parts of a parabola. Is up on the Google Classroom here as a handout, and we'll talk more about it for the next month. But before I go into anything else or answer any, before we move on, does anyone have any questions about parts of a parabola or anything like that? Does anyone have any questions on homework? Cool. Then real quick, let's see if I can address some of these questions that I've gotten on the Google form here, because we have a few minutes until our ASB person comes on in. I got a question that says, how do we, the math homework? So I don't know if that's how do we do the math homework or how do we submit the math homework. If you have a question specifically on how to do a problem, let me know. I'll get a video recorded for that, okay? I'll get that done for you for sure. If you have a question as to how to submit the homework, remember y'all that we are taking pictures of it and then uploading the links in the Google Classroom, okay? So if you wanted to submit, like say lesson 25, you take pictures of everything that you did in lesson 25 and then you drop it in there, okay? If you want to submit lesson 22, you take pictures of everything that we did in lesson 22, like say Aiden here, I would see if he dropped it in, if he uploads it like that. What about today's work? That's a great question, Caitlin. I will get that opened and posted for y'all to submit right after I'm done recording, okay? Because as of right now, it's kind of an insight. You see here all this kind of grayed out problems. These are all the things that I have scheduled to post, and today's work is this one, lesson 2. I have it scheduled to post thought it was today, but I guess not. Let's do this right now. Well, it should be posting right now. It's loading. There you go. It's up. So you can now upload whatever we just did today right there, okay? Because it's all, you have a link now, and that link is right here, okay? So feel free to drop that in there since y'all, if you did it with us, you should have it. Great questions. Anything else? All right. On that note, then I'm actually going to end the recording here, but keep in mind, y'all, we have about 5 more minutes until this ASB person, Logan Hubbard, comes in and talks to you about elections. So please stick around for that. I'm going to end the recording right now.